This is John Black, super chemist, here to talk about a Bronsted-Lowry acid. I want to go over the last acid we did, an aranious acid. That is, it always has to be in water. It has to be in water. And basically what it is this anything that when you add it to water, that hydronium ions are formed. So if you can put something that has loose protons, like hydrochloric acid, sulfuric acid, those protons will jump onto the water molecules and they will make hydronium ions, H3O plus. So it's basically a proton transfer via hydronium ions. The base accepts the protons, or is protonated by the hydronium ion. Okay, you can see over here, like a hydronium ion, the opposite, the base is anything that makes the concentration of OH negative ions in solution instead of protons. It's the opposite. So you can see they cancel each other out to make two water molecules. That really has nothing to do with anything. I just wanted to tell you that. But look at this thing here. Now, if you have HCl in water, right, you have to have water. You're going to put the HCl into water, and it'll make your hydronium ions and your chloride ions. That's what reacts with your base, is the hydronium. The hydronium will react with, say, this ammonium hydroxide, and we know it'll make salt water, right? 2 waters and 1 ammonium chloride salt. But since it's in water, it's in ion form. Now, what is a Bronsted-Lowry acid? It's the same exact thing. The same exact thing. The only difference is you don't have any water. Okay, if you have water, it's an aranious acid. If you don't have water, it's a Bronsted-Lowry acid. That's it. That's the only difference. Proton transfer. So it has nothing to do with making the concentration of hydronium ions or making the concentration of hydroxide ions. This is just purely about proton transfer. Proton transfer with no hydronium ion intermediate. It doesn't have to go to the water. There is no water, so it goes directly to the base. The base accepts the proton, same as up here, or is protonated by the acid, not protonated by hydronium ions. Because an aranious acid is HCl. The aranious acid is HCl because if you put HCl into water, it makes hydronium ions. That's the definition. Okay. But what if there's no water? If you haven't seen it, go ahead and look one up where they have HCl acid and they have ammonia gas. Usually they just have the acid and the aqueous base. But when they open them up, they fume. The HCl fumes out and the ammonia fumes out a little bit. You know what I mean? And if you see the fumes go together, they form this powder right in the middle of air. You know what I mean? Ammonium chloride. Now there's no water. So how does it happen? It happens the same way as up here. The only difference is instead of the proton going to the water, and then the water makes hydronium, and that's what protonates is. It just protonates it directly. You can see down here, right here. This nitrogen has its lone pair electrons sticking out there. You know what I mean? You got a nice planar this way, and this is like orthogonal. So it's sticking up, you know what I mean? This is would be like a plane, and these bubbles, these orbits rather, are up and down. So it's hanging out here, right? Proton, this comes by, electrons jump to there, these electrons jump to here, and then you end up with this negative chloride and this ammonium. But since there's no water, it forms the salt instantaneously. It doesn't form ions. It forms the actual salt. All right? And that's basically the whole thing. I want to go back to the thing. Remember the list that I said to memorize about positive and negative, proton and electron, acid, base, You know what I mean? Oxidizer, reducer. Remember that list? Well, remember, everything on the right is righteous, right? This is an acid. An acid is positive. It's righteous. So it can only do one of two things, right? It can either give you something positive like money, like protons, or it can take away, right? It can take away a bill, which would be an electron, right? That's something negative. You don't want nothing negative. You don't want a bill. Bills are negative. Money's a positive. Protons is money. You know what I mean? Protons are good. And in these cases, okay, both of these cases, they are talking about the acid being, if it gives hydrogen away, or gives a proton away, then it's giving, that's the positive thing it's doing, okay? Same down here. The positive thing that it's doing is it's giving a proton. It's giving you money. It's giving you something positive. A proton's positive, right? So if it's going to give you something positive, he is positive. Anyone that gives me money, I say they're positive. I say that's a positive person. I don't say they're negative. And bases are the opposite. You know what I mean? Bases, they're going to take your money. Or they're going to give you a bill. They're going to give you one of their bills and make you pay. They're going to give you something negative because they're on the wrong side of the list. They're on the left side of the list. They're on the negative side of the list. They're negative. They're not good. They're going to take stuff from you. You know what I mean? They're going to take from the base. I mean, they're going to take from the acid. They're going to take that proton. And they're going to accept it and keep it and hold on to it because that's what they do. They're greedy people. They're on the negative side. They're garbage. They're not you know, positive, great people like acids. No one's even heard of a base. You know why no one's heard of a base? Because they're garbage, that's why. Or acids, they're like superstars. Everyone knows what an acid is. If I say I'm going to throw acid in your face, you know I'm saying I'm going to throw something that's going to burn your face off. If I say to someone, you know, just an average Joe on the street, I'm going to throw some base on your face, he's going to be like, what are you talking about? But no one knows what a base is because they're evil, no good people. And so you know they're evil. You know they're not popular like the base. I mean, like the acids. Hey, acids are popular. Everyone knows what an acid is. You know what I mean? They must be positive if they're that popular. You know what I mean? I'm saying this because I want you to think of this way I'm telling you about positives and negatives. That tells you everything. If you learn that list, all you have to do is look at an acid and say, well, you're positive. So you must be either giving some positive thing away to somebody or taking some negative stuff from them. You know, taking their bad stuff. Man, I want you to look at this too. And what's a nucleophile? A nucleophile is just a negative entity that's looking for positive entity, right? Because if it's negative, it wants positive, right? Well, look at this. This is the nucleophile. How do you know? Because it's got the negative part. See there? This is the positive part, right? It's these electrons are going over here seeking this positive part. It's the nucleophile. This is the electrophile. Why is it the electrophile? Because it's positive. Remember, electrophiles are on the right side of the list. These must be on the left side of the list, right? Because they're negative. They don't have to be negative. Like this isn't negative, but it has a negative part to it. You know what I mean? These lone pair electrons, they have a negative charge. You know what I mean? They have charge, but the molecule overall is neutral, right? There's no charge on ammonia, but it's a nucleophile because this negative part is going over to this positive part. And this positive part, this proton, is going to jump over to here, right? It's going over to the negative part. It must be the electrophile. How's it on an oxidizer, right? Which one's the oxidizer? Well, this is giving this a positive proton. The oxidizers are on the right side of the list, right? So they're positive. You don't even have to learn the left side of the list. You just need to learn the right side of the list, the good ones. And then everyone else is bad. And they're opposite, you know what I mean? I learned that this is an oxidizer, right? Because it's an acid. Acids are oxidizers. It gives a proton. That's why it's positive. Oxidizers are on the right side of the list. So this must be the opposite of the oxidizer. It must be the reducer. Why? Because it's reducing this. This is neutral, right? HCl? HCl is neutral. But if it So it was a proton over here. Now you're left with a negative chloride. It went from not owing anyone and not um, having anything in the bank. It was neutral. It doesn't owe. It doesn't have any. It doesn't have anything. It's neutral. But when you took it away, now it's negative. Now it owes people. It's got a bill, and it needs. You know what I mean? It's negative now. You took me from neutral to negative. No one wants that. Would you rather be in a negative situation or a neutral situation? I'd rather be in a neutral situation. So this is the oxidizer because of that. You see, they're all the same thing. An oxidizer, but why is it? It's just a little slight definition, like it's a nucleophile because, not because it's negative, but because it has something that is negative that is seeking out something positive. And this is the reverse. It has something positive, this proton. It's seeking out something negative, these lone pair electrons. I can't think of what else is on the list. How about HOMO and LUMO? HOMO is highest occupied, so that would be this one. So this must be, HOMO must be on the left side of the list, and this is LUMO, lowest unoccupied, because the hydrogen gives up its electrons from its orbit. So when this goes to the anti-bonding orbit, it kicks that out, and the hydrogen comes over to here. Trying to think what else is on the list. I don't have that list handy, but you can do that with anything. Why is this negative and why is this positive? Because it has these lone pair electrons. Why is this positive? Because it has a proton. Protons is money, electrons is debt, is bills. Right? So why is this on the left side of the list? Because he's garbage. He's got these electrons. He wants to, jump. They're way out here above the plane, trying to, just dangling. It wants something positive to. Anyways, always remember science is great, and you all have a great day.